Hey everyone, it's Mrs. Brimlow, and today we're going to start talking about how to solve equations using square roots and cube roots. There are some notes. For right now, I want you to just watch the video if you're at home, or if you're rewatching this just as a refresher, feel free to have your notes out or just watch. Tomorrow, I will link a copy of the notes finished because we're doing part one today, part two tomorrow. I'll link a copy to the weekly syllabus that you can refer to. But once again, for right now, you can just watch the video. So to set the scene and stage for our first example, we're going to watch about a 30-second clip of this video, and then we're going to dive in.
How can you solve equations with squares and cubes? Think about this question during the lesson. Darius is restoring a square tabletop. The area of the tabletop is 25 square feet. He wants to finish the outside edges with a piece of decorative molding. What total length of molding will Darius need? Darius begins by drawing a diagram to represent the tabletop. He needs to find the length of the sides. Use the formula A equals S squared to find each side length.
All right, so I'm going to stop here with the video so we can see what we're looking to solve. I'm going to switch over to the notes. So once again, this is what the notes look like. So the first example is, what is the total length of molding that Darius will need? So I liked how they draw a diagram. I'm a big fan of the visual, especially when you're working with shapes. So we know that the area of the square is 25 feet squared. What we don't know is what each side length is. Okay? However, we do know that squares are based off of side times side when you multiply a number by itself. So we know that to find the area of a square, it's S squared. That's where that formula comes from. So we're going to replace this with what we know. We know the area is 25 feet squared. We still don't know what that side is, though. Okay, that's what we're trying to figure out. So whenever we're solving equations, we always want to do the inverse. For example, if I saw addition, then I'd want to do subtraction. If I saw multiplication, I'd want to do division and so forth. That's the same thing here. So the inverse of squaring a number is to take the square root. And we know what we do to one side of the equation, we do to the other. The square root of 25 is 5, okay? And these cancel out, leaving you with S. So that means each side is 5 feet, okay? So if we go back to the question, it says, what is the total length of molding that Darius will need? Well, we know that the molding will go around, and when we're talking about the distance around something, we're talking perimeter. So this is part one of the problem. We still have to do the second part. So we did use this formula to find each side length, okay? So I know that there are 4 sides, and they're all the same because it's a square. So when I add that all together, I get 20 feet. So therefore, Darius is going to need 20 feet of molding. So I'm going to write that. So this was a 2-part question. Once again, coming back to the equation piece, when we solve equations, we always want to use inverse operations. Okay. We're going to take a look at our next example. Okay. So Kyle has a large cube-shaped terrarium for his iguana. He wants to cover the opening with a square screen. What are the dimensions for the screen? Okay. So for your knowledge, since I forgot to put this on the notes, the volume of this cube is 343 feet cubed. Okay. And once again, we want to use that 3 because we're talking about cubic space. We're talking about volume, and we're talking about a 3-dimensional object. So we use 3. Okay. So let's talk about volume. So we know that volume is equal to the side length cubed. Okay. And they did say that it was a cube terrarium. That's why I can use this formula, okay? Which this is just side times side times side. So I know the volume is 343 cubic feet. I still don't know the side length though. So just like we did with the square roots, we want to use the inverse operation. So to do that, we're going to take the cube root. Now, when you take a cube root, it's the square root symbol, but you're going to add a 3 above what I like to call the little tail of the radical to show that it's a cube root. Okay, so if you wanted it to be to the fourth power, you'd put a 4, so on and so forth. Square roots, you can include a 2, but it's just not what we typically see. Okay, so when I take the cube root of 343, I get 7. So that means each side of the terrarium is 7 feet. Okay, so 7 feet high, 7 feet wide, 7 feet long. Okay. So that is it for today's lesson. There is some practice listed in Canvas or whatever we're working on in class. You can find in the weekly syllabus. Excuse me. If you have any questions, let me know. I will chat with you soon.